Hi, welcome to another 4AC video. In this video, we want to continue with 4AC topic 4, AC power. Now, in the previous sessions, we learned about the average power delivered to an AC circuit. An AC circuit is very typically drawn this way, where we are given a black box with some components inside, and we measure the current waveform given usually a fixed voltage waveform, which is most of the time the case. And from this, we can then calculate what should be the average power. Right? And the average power is given by this formula. The P power is equals to the E, which is the RMS value of the voltage applied to the circuit, multiplied by the current, RMS current, that is flowing into the circuit, cosine of the phase angle of the voltage, which is the E, minus the phase angle of the current, which is I. Right, and this is expressed in a unit called watts. We refer to this as the effective power, P, or sometimes we call this average power. Now, this is basically the power that is effectively converted from an electrical to a other kind of power. Now, the other type of power that we can determine in an AC circuit is what we term as apparent power. Now, apparent, the word means that it is basically the power that is available to a circuit. Right, and we will want to understand why it cannot all be taken out. Right, so we say VI is the power virtually accepted by the circuit, but not all portion of this power will become effective power. Right, so we use the term apparent power, or the symbol S. Right, for it. So S is calculated by just taking the magnitude or the RMS value of the voltage multiplied by the RMS value of the current. So again, what proportion of this apparent power would become what we call the effective power? Right, and actually it is determined by the power factor, or sometimes we just say PF, or we give the official term F with a capital letter with a small letter p. So power factor is calculated by the cosine of the initial angle of the voltage minus the initial angle of the current. Another way to look at it is power factor is the ratio of the effective power over the apparent power, or P over S. So that's the reason why a power factor has no units, because power factor basically is the ratio. So let's look at an example of AC power circuit when it's only resistive. Now you may recall that in a resistive circuit, the current and the voltage are in phase. In phase meaning the difference in these two angles are 0. So cosine 0 is equals to 1. It means that in a resistive circuit, the effective power PR is VR times IR, which is also the apparent power. Right? Because in a resistive circuit, there is no reactive power. So PR, or the effective power, can be calculated as VR times IR, or if I replace VR with IR, remember Ohm's law, then I get PR is I square R times R. Or another way is PR is just V square R divided by R. Then what happened to the apparent power? Now, by definition, apparent power is SR is equals to VR times IR, which is similar, if you will notice, as PR. That's because the power factor is 1. Now let's look at what happened if the power dissipation of inside an inductive circuit. Let's example this way. Right, in this example we have a resistor and an inductor. Now if you recall, for a pure inductive circuit, the current and the voltage are 90 degrees out of phase. This means that the power factor is the difference between the phase shift of initial phase of the voltage and initial phase of the current, which is 90 degrees, and cosine 90 degrees is 0, which means that the effective power in the purely inductive circuit is 0. The average power is 0, and the apparent power is SL equals to VL times IL. The apparent power is 100% reactive. Although the pure inductive circuit does not dissipate power, but there is energy going in and out of an inductive circuit. So such energy movement forms the reactive power, which you use the term Q. And is given by the formula QL is IL square XL, or VL square over XL, or VL times IL. And the power factor for a purely inductive circuit is cosine 90 degrees, which is 0. Now we look at power dissipation in a purely capacitive circuit. If you look at it, a purely capacitive circuit, as the current and voltage are out of phase again by 90 degrees. So we can deduce for the same thing, the effective power, because the cosine minus 90 degree, or the power factor, is also 0. We can conclude that the average power in a capacitive, a purely capacitive circuit is 0. And the apparent power can be calculated as SC equals to VC times IC. Similarly, the reactive power, we define it as QC. Reactive power for capacitors QC is equals to IC square times XC equals to VC square over XC, or VC IC. And power factor is cosine minus 90 degrees, so it's also 0. So only a purely resistive circuit will have dissipation of power. Okay, we will stop here for this video and continue in the next video, video 4-3. Bye bye, see you.